My name is John Kanagaraj, and I represent Couchbase at eBay. All right, let's get started. Quick introduction to the agenda. I'm going to talk about eBay. Why did we choose Couchbase? What are our use cases? What are our current deployments? And the challenges we faced in some of these deployments. How do we operationalize it? What is in the future for us? And hopefully we'll have some time for Q&A at the end. So a little bit about myself. I'm a data architect and a database engineer at eBay, Inc. I've been working with Oracle for a very, very long time, 3 decades, in fact, too long. I'm a frequent speaker at Open World and other technical user conferences, but this is my first one at Couchbase. I have a lot of admin experience with Oracle, but my experience with Couchbase began probably early this year. I had an introduction to other NoSQL databases earlier in the year, at the end of last year. So let's move on. A little bit about eBay. As you can see, we have a lot of internet properties. We have been around for a very, very long time. We are the leading e-commerce site. In 2002, we acquired PayPal, and PayPal grew and grew and grew. And PayPal, in turn, acquired PayPal Credit, through which we offer credit to merchants and to customers. And we recently acquired Braintree. So you will see a sort of division between the two, and that's coming up. That's in the news already. But there's a lot of synergy that we have between the two, and I believe that we will continue with that synergies. But I'm going to be talking about eBay marketplaces today, on the left-hand side of the slide, the previous slide. And one of our colleagues is going to be talking about the PayPal side later on. So we have about 100 million active buyers and sellers, 600 million plus items on any given day. During the holidays and peak season, this could go up 700, 800 million items. We get about 2 billion page views a day. Obviously, this is going to peak during holiday season. We have a ton of database calls, 80 plus billion database calls a day, most of it going to our older Oracle systems. And some of this, I hope, will be taken into our Couchbase system, so we'll talk about that. A lot of storage, a lot of disks, and a lot of servers. So if you look at the database landscape at eBay, we've listed everything there. Obviously, Oracle is pretty big. We have MySQL as well. We have other NoSQL deployments, Couchbase, Cassandra, and MongoDB. And on the right-hand side, we have, in the analytical space, we have Hadoop and HBase and Teradata. But I do want to bring attention to the fact that we run hundreds of databases across the site using multiple technologies. But the key is to choose the right technology for the right use case in order to be successful. So why did we choose NoSQL? I call this my 4x4 slide, and I'm going to give you 4 different pieces in 4 points in each of these pieces. So we have challenges, many challenges with traditional RDBMSs. Acid overhead inhibits scalability. There's lack of native sharding. You have to build in your own sharding. You have to build in your replication. And for developers, there is a limitation when you want to talk to Oracle DBAs. You have to provide the schema up front. And that's a problem when you want to be agile. And there's usually a higher base cost, right? But there are a lot of advantages as well. ACID, the requirement of ACID is essential in many cases. I wouldn't want to bet my money transactions on a database which may have some issues, right? So if it's not ACID, then you might not want to put that there. So there are cases where we do require ACID, and that goes into a relational database management system. Complex data models, ERP systems, obviously, you're going to use RDBMS as well. It's a mature technology. There are a lot of ecosystems around it, and skills are widely available. But then you come to NoSQL, where you have highly scalable databases, lower cost, you can scale them out quickly. These are web scale. When I say web scale, we are not talking about hundreds of transactions per second. We are talking about thousands and thousands of transactions, even 1 million transactions per second. So when you come to that, the whole paradigm shifts. So how do you want to store all this data? How do you want to process it? You do need to use NoSQL systems, right? And the flexible schema that comes along with it is, and the support models are, it's both open source, you have enterprise, you have a choice of which to use. But there are challenges with NoSQL as well. As I said, if it lacks assets and transactions, you might want to consider the kind of use cases you want to put there, right? How many of you know CAP? You know what CAP stands for? Consistency and availability in the presence of partitions, right? This is real when you come to distributed systems which are used for NoSQL systems. The NoSQL area is still fragmented, it's evolving, it's growing, and we hope that Couchbase has continued to be a key player in the space. It's certainly not the only player at this point of time, although Couchbase would like that to be there. But I think Couchbase has a very, very strong presence in this area and is continuing to grow. We do have a challenge with skill sets. It's not widely available yet. It's geo-located, I would say, around the Bay Area. But you know, we are in a situation where we were before with Oracle 30 years ago. And in the world of NoSQL, this is changing very, very rapidly. And I'm sure in the next 2-3 years, a lot of these challenges are going to be taken care of. All right, move on. So why did we choose Couchbase? It's open source. Enterprise models are available with support. It's a memcached. It's ideal for caching use cases, for which we use it a lot. It's low latency, 1 millisecond or less on read and write. We tested this on one of our bare metal boxes, and this is the kind of performance that we got, like 300,000 reads per second on one server. And this is where I'm talking about. There's no way I would build an Oracle system to provide this kind of performance. The cost would be astronomical. 25K writes per second on one server with a low replication queue. I just want to call out the fact that this was done on 2.2. There's a lot of changes coming. 3.0 has got a lot of promise in front of it in terms of the replication. It's capable of a burst write of 100,000 writes per second, but we did find some problems with the disk queue, so we throttled back. So this is another important point, ejection of values for larger or inactive data sets. This is going to change in 3.0, but we found that this is the guarantee that my key is going to be available in memory was critical for us. So you can easily add dynamically, add capacity without downtime. All these things are great, and I think all the rest of the speakers have given wonderful ideas in how this can be done. And there are a lot of sessions in the next day to cover some of this, so I would encourage you to attend that. There's client support for multiple languages. We deal with Node.js, Java, and so on, and this support is widely available. And cross-data center replication with multi-master clusters was an important requirement for us because we run active data sets in multiple data centers. Quick self-healing on node failure and ease of maintenance. This was just absolutely fantastic. So within 30 seconds, you recognize that there is a failure. Within a minute, everything gets healed, self-healed. We are good with that. The technology is still maturing, but we found it currently a best fit for caching. I'm not saying that's the only use case. There are a lot of use cases which are going to come in the future, but for now, this is what we use it for. So let's talk about object caching patterns. I'm going to take up one use case where we talk about read buffering, which speeds and optimizes access to system of record. System of record, in our case, usually is an RDBMS, mostly Oracle, some MySQL as well. So this frequency access data is cached in Couchbase, in the Couchbase layer. We can use it for reference data cache. You can use it for result set caching. But the other use case, which is also evolving, is write buffering, where we can store session cache and token store and cookies and so on. We are currently using this for the first use case, but we believe that there are possibilities that we could use it for the other ones that I listed, where I can stage bursty logs when something comes in a burst. I can quickly write it to Couchbase and then drain it from there to wherever it needs to go. I can use it for in-flight CEP, which is complex event processing. A lot of things need to happen within 500 milliseconds for us. We need to make some risk decisions in the PayPal world, and we believe that there is an area where we can use these fast caches to write, accept these writes, perform some calculation, and create some new models for risk. Well, a rate limiter is another one. We'll talk about that, right? So let's move on into what we have already implemented in eBay marketplaces. Two deployments I'm going to talk about. The first one is a view item read buffering. The image that is shown there is a current image of what you see when you log into eBay. So the eBay homepage is going to show you multiple items, maybe deals of the day, maybe the categories that you want, and so on. There's going to list multiple items in the same page. But when you click on a view details, a detail about that particular item is going to pop up and fill the screen. Now, there's a lot of metadata that is going to be shown in this screen. You have user details and so on and so forth. Metadata around what is the type of item. Is it a, does it have an expiry soon? What are the kind of other things that are happening around that view item? All that is cached in the Couchbase layer, and this is what we use to speed up. Basically, the idea is to enhance the user experience and serve as a cache in front of our SOR. So how does this look? So the items are listed by the seller, goes into this cloud of eBay applications, and from there it is written into our SOR. You can see a metal spinning disk there, deliberately put. It's a slower disk, right? So with the size of the data that we have, we cannot obviously cache all of that in memory. So we do write it to an SOR, but we want to be able to read that very quickly. So what do? We cache in front of it using Couchbase. This current configuration has it's 2 clusters in 2 of our main data centers. These are 4 servers at this point of time, Dell R620, 512 gigabyte RAM, 1.6 terabyte SSD. This is actually 4 disks. It's in RAID 1+0 configuration at this point of time. We have 1 bucket which contains item and user metadata. The size of the metadata is about 2 to 3K. This is not the Couchbase metadata. It's our item and user metadata, right? So we cache about 700 million items at this point of time and about 150 user-related rows in the same bucket. What do we do with this? We support multi-channel, multi-flows. And I think this is something which the message is consistent throughout, right? Whatever your site, you need to be able to provide the mobile experience, the web experience, and everything else in between. And to do this, Couchbase is a great platform. Reads are sped up when the view item details are clicked, as I showed in the previous page. We are still ramping up at this point of time, and when it is complete, we're probably hoping to serve about 2 billion reads per day. The clusters that we started out with are 4 at this point of time. We are looking at the sizing and moving this up as we scale this up. So one of the most difficult problems with caching is to keep your cache consistent with what's going on under the SOR, right? So as sellers and as batch items and other things go and modify the SOR, we need to make sure that we fit that back into the cache. Otherwise, the cache is going to be inconsistent. So we do that in a couple of ways. One, we have a special DB listener that we use. We use that for doing a lot of things, including movement of data. We are hooked into that, and we have developed an interface which goes and updates the cache. So all the items that get modified will get changed in the cache at that point of time. And the application, if it reads before that, it also recognizes the time that it was last updated. And if it thinks that this is something that needs to be changed, can go to the SOR directly and update that back as well. So it keeps this cache. There is a slight period of time when it could be inconsistent, but we are willing to accept that. OK, moving on. We do use XDCR between the two. This is a bidirectional XDCR. So we have some protection on both sides. So the items expire in the SOR and in the cache after a fixed interval. And these two things can go their separate ways when it expires. Right, so the next use case is a write buffering use case. The previous one was a read buffering use case. We are talking about a session in a token store. So our auth tokens are stored in Couchbase. This token is created during login. It is a token which we use to ensure that the session, a long-lived session on eBay, continues to be valid, right? So this is written to Couchbase and read back during reauthorizations. So if, let us say, if you logged in, you were idle for a particular time, and then you came back and did something, we need to make sure that nothing got changed underneath as a user at that time. So we'll reauthorize at that time, go back and read Couchbase. So this provides us a new platform for extending and creating new authorization policies, including account takeover policies that we previously sort of throttled because of read rates from an SOR. Now it gives us new possibilities, right? It's created as a service layer to support both legacy flows and new flows. And the point, I put that point in there to emphasize that the presence of a very, very fast write cache opens up new possibilities for us, and that is enabled by Couchbase. So also need to look at the negative side of that. So this is the only store. So we don't store the token elsewhere, right? So it means that we need to protect that token store. We obviously do that by XDCR. We replicate this to multiple clusters. We're running this in 3 data centers, and we replicate triple way to all the data centers. So if there is a single node failure in each of these data centers, obviously the tokens that are related to that particular vbuckets that are affected by that particular node will return an error, but that'll be a very small percentage. And the self-healing properties of Couchbase allows us to recover from that very easily. But if we do have a larger failure in the cluster, then we do have to move traffic up through the whole stack and go to the other side. So there is some potential for impact. That's a concern for us, but I believe we mitigate that as well. OK, so what really happens in this case? User logs into eBay. A token is generated. We write that to Couchbase, and it's about 100+ million per day, right? So there are 3 clusters of 6 Dell R620s, 128 GB RAM. This is on slightly older machines. We have 1 TB hard disk capacity in each of these nodes. So we have a single bucket in there. It contains the tokens, nothing else. And what happens next? So tokens are reread during session revalidation. Obviously, we write once, but we read multiple times. We have set up bidirectional XDCR between 3 data centers. So if you look at the difference between this slide and the previous one, the previous use case ran on 2 data centers. This one runs on 3. And there is bidirectional XDCR between all these 3 data centers. So the tokens expire after a fixed interval. And as I said before, we support multi-channel, multi-flows in all these use cases. Nothing is without pain, right? So challenges and pain is part of growing up. And one can only become mature when we go through these problems. So we do have our challenges. This was one of the earliest of the use cases in Couchbase in the eBay marketplaces side. So we had to do a lot of skill ramp up. We were helped by the fact that the same group to which I belonged to in PayPal before also moved over to eBay Inc., supporting this use case. So we did have some, we had a few DBAs who were familiar with Couchbase. We had to expand that and skill ramp up on with many other people. So on the dev side as well, we had to have some ramp up. So went through some learnings there. Throughout this, Couchbase support and engineering provided great support. We had Neil. We had him. I've had a lot of calls with Neil, and we had a lot of calls with support. And we went through a phase where we had some difficulties, but that was quickly, determined. Support came and helped us, and I'm just going to list some of them. So we had a situation where in the initial days, nodes were going into pending state intermittently. So the problem is when it is intermittent, then we do have some concerns, right? So we tracked that down. We had a lot of email exchanges, log exchanges, and so on. And Couchbase found that we tracked it down to a new XDCR bug in 2.5.1. Hotfix was delivered recently, and we are testing and implementing it. That's in progress at this point of time. A reconnect from clients failed intermittently. This was another bug that we had with the carrier publication protocol. This was traced down to 1.4x, and a client fix was delivered, and we are testing and implementing that as well. So the point is that when you're running things at scale, there are some corner cases which do pop up, right? And this is what happened in our case, and we did engage support, and as I said before, support helped us through this. So we are currently dealing with some inconsistency in the XDCR replication. Analysis is in progress. I do want to point out that we had this particular cluster where we have this problem is on 2.5.0. It's not 2.5.1, so we are looking at the hotfix and so on, fixing that. I'm sure it's going to fix this problem. So I'm going to shift gears and move a little to how do I operationalize Couchbase, right? I come from a database admin background. My background is in support as well. And there is a lot of things that you need to do when the rubber really meets the road, right? All the well-played, well-built plans have to eventually meet reality. And when that happens, there are problems, right? So as a user, I believe this is a great place in the Couchbase Connect conference to come together and share these war stories and figure out, how's the best way to move forward, best practices and so on. So basically what I've done here is to list a few best practices that are in my mind when I want to operationalize Couchbase. So let's start with the provisioning. So when I look at provisioning, one has to think about whether you want to do it internally, want to do it externally, right? So when you do it externally, you have the Amazons of the world, Microsoft, and so on and so forth, where you can build your clusters there. So you already have a ready-made model. It's already available, multiple zones, multiple failure points, and so on and so forth. So that gives you the advantage if you go external. But if you do internal, you have you have control over what you're doing. You have control over greater details of what is going on inside. And if you're doing it internal, whether you're going to do VMs, whether you want to go bare metal is another question that you might need to consider. Monitoring, alerting, and metrics. So this is an important piece for us. As an operational DBA, I need to make sure that when something goes wrong with my cluster, I need to know immediately, right? So there are inbuilt alerts in Couchbase that you should configure and you should use. And this is your first level of defense, right? So a number of things that are listed in there. I'm not sure if 3.0 is going to add some more alerts into this. Just make sure that we use these alerts. Send email to either a pager or a DVADL, which is monitored. But that is not enough. So we have a very, very well-matured ops board, which is monitored 24/7 by a specific dedicated team, which operates in 8-hour shifts. So we need to be able to take these alerts and send them into that board in a structured way. Because as you remember, I said that we deal with multiple database technologies, and I cannot fill the board with just a Couchbase cluster, right? So we do summarize a lot of this information. We built our own tool to put this into a console. And I can see in my ops board, there's a Couchbase tab, which we built specifically for this. And then if there's anything there, it's going to blink, and then we can have the ops guys go in there and take an initial look. Collecting, storing, and alerting using CB stats and other OS metrics. So CB stats produces a ton of metrics. And right now, at this point of time, there's a parallel session going on from our solution architects who's dedicated to us, Justin Michaels. I would suggest that you go take a look at his slides and look at what are the things that you need to deal with when you're talking about CB stats metrics. We also collect OS metrics, and we summarize all of this and send this to the right places and store it and do all sorts of things with it in Nagios and Zabbix. Performance tracking leads from the metrics that we collect previously, right? So we need to measure not only the database side metrics, we also need to look at the client side metrics. And to do that, we need to have some kind of logging on the client side. So we have built our own framework to be able to do this. We log at very, very great detail and depth. We know exactly which calls are coming in and how much time they're taking. We track this very, very closely. Capacity management. So there's another great session that's going to be conducted by Perry Krug. I'm not sure what time it is. You can look it up in your schedule. Consider going to that, because it's very, very important that you size your cluster correctly. So some of the points, the ones that push the envelope, RAM obviously is number one. How much of your data set you want to cache in memory, and how do you want to serve that directly out of memory does matter. CPU, not so much, but when you talk about indexing and adding views, then CPU does come into consideration. In terms of the disk storage, I would suggest that you use top-of-the-line disks, because when you have cache misses, you want to be able to provide disk reads as something which is close to what you got from the main memory. I/O saturation can happen, especially when you're doing some rebalancing, as network as well is something that you need to consider to make sure that you have at least 10 gig network when you're looking at connecting all these clusters together. Next one, capacitizing for failure. You need to look at the number of nodes, because that will determine a couple of things. One is going to look at, you're going to think about the number of copies. So the larger clusters you have, the possibility that you will have more than one node failing at the same time does increase, right? So when you do that, then you need to think about maybe changing your replication from the default of 1 to 2. Percentage load shift. What do I mean by this? So let's say, for example, you start with a 3-node cluster, and one of the node fails. You're going to have to shift 33% of your workload, CPU, memory, all the vBucket rebalancing, and all that is going to happen at that time. It is possible that you can, depending on the kind of load that is being served by this cluster, you can quickly overwhelm the other ones, right? So we suggest We always start with a minimum of 4 in our case, so 25% is something that we can accept. So think about that when you capacitize. Think about having spare nodes for swap rebalancing as well. And of course, key to this is to say, okay, this is what we thought is going to be, but to track what is really happening, you need to be able to trend the metrics that I talked about previously. And not just trend them, but review them periodically. And you, of course, cater for organic growths and peaks. So for us, both in eBay and in PayPal, we need to make sure that we are prepared for the holidays. We capacitize for the holidays. XDCR and data protection. XDCR-based failover protection is essential. You need to think about whether you want to do bidirectional, you want to do one-way, and so on. So what do you do when you have multiple data centers? Are you going to allow cross-colo calls from your main application center? These are things that you need to think about when you architect your Couchbase clusters with XDCR. What about network bandwidth, right? So currently, if you look at 2.5, and I need to clarify this with Shihan, but in 2.5, the XDCR that is being sent across is deduped. Any changes that you make in the main memory, in the RAM, with a very, very fast rate, all those mutations are going to be shrunk and deduped, and only the changes sent across. But in 3.0, that is not going to be the case, because you're going to do memory-to-memory XDCR. So there is a change depending on the pattern, depending on the kind of updates that you do. The network bandwidth requirement for XDCR is going to increase. So keep in mind all these things when you design this. Right? CB backup versus file copy. That is changing as well in 3.0, I know, so I'm not going to talk a little more about that. Let's move on and look at what happens application behavior at scale. And I wanted to point this out to say that when you're operating at the scale that we operate in, we have maybe about 10,000 application server nodes. All of them are making connections into the cluster. So it needs to have two sets of connections. One is to the cluster manager, 8091. Another one is the data port, 11210. Right? So when this happens, we are going to see a large number of connections. And so one way to tackle this is to look at using client 1.4, which says you can use the carrier protocol. It changes the protocol so that it can reuse the data portion to do the cluster management, cluster map updates, and so on and so forth. So think about connection management. Think about what happens when a node fails or a cluster fails. And when it comes up, there's going to be a connection storm. So in 2.5, everything is just going to come in. But in 3.0, I believe there are some changes where you can do a much better way of doing this. So that's another thing that you need to think about when you're going to look at the new features in 3.0. Think about how your applications behave when a node fails or a cluster fails. So we typically have fail open cases. So when we use the appropriate timeouts to make sure that when a node fails, that we don't cascade this failure over to the application. Right. So next one, data modeling and governance. So this is something close to me as a data architect. I do the use case validation, and I need to think about the 4x4 slide when I talk to customers, right? When they say, hey, I want to have Couchbase, or I want to have some other NoSQL, I need to make sure that their use case is correct. So you need to think about how your data model will not just start, but how will it evolve? Will it come into a situation where you want to do indexing later on? Now, you might start with a key value store right in the beginning, but your use case might change so that you need indexing. So when that happens, you need to think about, how am I going to allocate memory? How am I going to allocate memories for the views? How am I going to manage my disk space for my indexes and so on? Currently, we try and see if we have some kind of validation which says we are not going to put any PII, personally identifiable information, in Couchbase at this point of time. But with the unstructured data, we really do not know. So we are looking at ways to say, how do we govern this? How do we know what is going in there, right? So this is a challenge that many others would face as well. And of course, data recovery and impact is something that is on top of our minds. We make sure that the applications understand the failure modes and cater for them. Security. You need to have some kind of layered security. Make sure that you don't expose your Couchbase cluster right to the web front end. Put in the appropriate number of firewalls and so on. How do you access passwords? Who has access to the passwords? So for example, I had a question earlier today where we talk about who creates the views. Typically, it's developers who create the views in both the development and in production, right? In the case of Couchbase, you might want to say, no, DBA still have the admin password. DBA still do the manage the views and so on and so forth. You give us the code, we'll implement it. So you need to think about that. Data lifecycle management. Implement retention policies, use time to live, make sure that you're not going to fill up everything just because it's a cache. You need to make sure that you have the right TTLs built in right from day one. It's very difficult to implement that later on. Change management. This is something that, so one of my friends said, agile is fragile. I do not necessarily agree with him. You need to be agile, but you also need to make sure that changes in production go through some sort of process where there is another eye looking at it and saying, okay, these are the changes that we did. Because when some change goes bad, we need to be able to backtrack and change. So change management is a necessity. Some process is a necessity. How do we deal with this in the NoSQL world is something that we're still figuring out, right? Especially with the fact that you have unstructured data and you can change your structures. Is a little, it keeps me up at night as a data architect, as DBA. So building in governance and linking that to your change control is also essential. Support. This is a big point, and this is something that I've heard in all the other NoSQL implementations as well, right? This is a new area. There's a very, very small pool of people who are really skilled at what they're doing in this world. So my recommendation is that you do leverage Couchbase to its fullest extent. There's a lot of training, and I believe there is a training session after this conference. If you are going into Couchbase, I would recommend that you send people to this training course. We have a wonderful set of people from Couchbase who can get into all the nitty-gritty and show you exactly what's going on behind the scenes. So there's many more, right? Licensing, cost management. How do you take this data from the Couchbase back into your Hadoop? In our case, we needed to do that for one of our use cases. We're building that still, right? So if you go back to my 4x4 slides, as I said, in the RDBMS world, all these ecosystems are already built. All these things are already in place. So in the NoSQL world, we are still building some of that. So keep that in mind when you think about how do you plug this new technology in. So a number of use cases are lining up for Couchbase. Global preferences on the eBay side, eBay cookie store, which is specific to eBay users, eBay's mobile identity cache, taste graph, notification inbox. There's a ton of stuff where we believe that Couchbase is going to speed up a lot of things. These are use cases that are lining up. We are already in our ramp-up and holiday preparedness mode. We looked at all the clusters. We're going to add capacity to them and get ready for the holidays. We are conducting a lot of internal training and training awareness. We have some workshops. I personally go and talk to a lot of people to make sure that they understand what they're getting into and how to use Advantage and so on and so forth. Finally, Couchbase 3.0. That's coming out. And for us, it's an exciting product. there's a use case that is already just, raring to go and use Couchbase 3.0. We're still testing it, and I believe there's already a 3.01 out, so we'll take a look at that. So I have just 10 seconds for Q&A, but I believe I have Neil has something to say.
Thank you, John. This is for you.
All right, thank you very much, Neil.
Thank you so much for being the speaker here.
Thank you.
I want to just add that the value, or the magic, if you want to call it, the value of Couchbase is represented in two facets, really. One is our product, which I think almost all of you use and have seen, and the other is the team behind it, whether it is sales team, support team, pre-sales team, solution architect team, product management team. And it is with customers like eBay and PayPal where you push us to the limit, right, both on the product side as well as on the team side. And we are really proud to have you as a customer. So thank you again.
Thank you, Neil.
Thank you, everyone, for listening.
Thank you, everyone.